it's also going to be looking for whether it's above 2,000, but we'll look at that in the program. And then where it says R, notice that if we count up from that one, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So starting from 0, that's the 9th place. So we'll look in the program where that is also mentioned. The first, where it says any 3 cars, means any 3 of anything. A car is any type of character, whether it be a number, punctuation, letter. So that's basically anything. And then we said where the R is, starting from 0, that's the 9th place. So the 10th place, if you're counting from just how many. So let's look at it in a clip so we can just see it better. We can see it where we're going to run it. So we have this program. It's going to scan in something. It's going to go into a string. And then notice that we have a car that is called zone. So remember, a car is 1 letter. And then we have 3 ints, district, valid, and band. So the string is code. So code is going to scan in a string from the user. And then there's a while loop that says while code doesn't equal uppercase XXX, then keep taking in an input. So essentially, you're allowed to enter in product codes until you enter in capital XXX. If you enter in lowercase, it won't work. We'll talk about at the end, like how you can get rid of the ambiguity of whether it's upper or lowercase. You could just do a 2 upper and have all the stuff be uppercase, but it might change some of the ways that the characters are entered. So for now, we'll just leave it this way. But if you do enter lowercase XXX, it will not stop the program. But it will tell you that the string is too short. So first we'll just look at the program, and then we'll ask how are the various exceptions caught, under what circumstances. Okay, so we've got a try. So it says, so after the user enters in their string, which is stored in the string variable code, there's a try block. So it says zone, which we know is an int, equals code.caret2. So this says, so let's go back up and just do experiment. Zone's a car, right? So I actually haven't changed this. This is originally supposed to be 9 because I was playing around with the program myself just to test that the exceptions were working where you're supposed to. So remember that the 9th place is where that R was. So this is saying take the string code, go to the 9th place, and place it into the variable zone, which is a car. And then district is an int. So it says integer parsed int substring 37. So that's where I counted up that it was 4th place, and then there were 4 digits. That's where this this substring is used. So let's go back and look at the slide for a second and just look at these 2 pieces. So we're looking for the place where the R is, and it's going to be placed in zone. And then the place where there begins a 4-digit number at the 4th place beginning from 0. So 0, 1, 2, 3, 4. That's where the substring 37 will be able to get the data. So we look at this. So going back to this. So the zone equals caret 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's where the R is. And then the place where it's got the substring 37, 0, 1, 2, 3, 4, 5, 6, and then we know that substring works where the first number is actually used, and then the last number is where it ends, but it doesn't take the seventh character of the substring. So it's going to take 1704 if we happen to enter this one. And then the first part says any three cars, so we can enter in any three numbers. So I'll enter in this just to put in something that's familiar, and then I'll enter in just one character, and we'll see what error type we get. And then I'll enter in a whole lot of them, like 12, and see if we also still get an error, so we can determine what's throwing the try-catch by experiment. So we look at that part where we had the district, which is going to be parsed into the int. So it says if zone is R, so if the ninth character is the character uppercase R, and the district, those four numbers, equals 2000 or above, then you tick up the variable band, just for arbitrary sake, to see if whether this try-catch is working. So this is part of the try-catch mechanism as well. Although the catches will be down here, so we'll see those in a second. So we see zone, we see district, and now let's look at the two types of catches that are in here and think about where they would be from. Okay, so one says string index out of bounds exception, improper code language. So there are two lines in the program that can throw a string index out of bounds exception. Anybody want to guess one of them? So meaning, if the thing wasn't long enough, or was just something that would say, if you needed a 4-element array and you put in 7, that would be out of bounds. Or if you were probing for a character that was in some array element that didn't exist, that would be an out of bounds. So let me see if I can keep these two catches on the screen when we look at the two places. I'll shrink the text a little bit. So now we can see them. So the two lines that will throw the string index out of bounds are visible right now. Anybody want to guess one of them? And you don't even have to say why. Yeah.
Second one?
Which one? The parsing?
Yeah, substring.
So what do you think would do that?
Your code length is less than, I guess, with 0 base 6, then it won't like get the substring.
It won't be able to get that character.
Yeah.
Yes, so that's a good one. So if we put in like below the amount that's needed to get to the end of the substring, it'll throw an array index out of bounds. So let's just throw in the number 3000. But I'm also going to comment out zone equals code car at 9, so that we see that this is actually, district can throw the error, but there is another place that can throw the error too. So where it says zone equals code.car at 9, I'm going to change that 9 to a 2, just so that we, there'll be a character at position 2, so that won't have any problem. But I'll make it only 5 characters long, because we'll see that this is the other line that can throw this index at that error. So if I change this to 2, we just need to have a car at 0, 1, 2, third spot, whatever we have. So I'll put in 5 letters, and that should throw a string index at bounds. So notice that this is a parse int, so this also has the possibility of doing an input mismatch, but it won't throw an input mismatch if the string isn't long enough. That would be something else. And also notice, I don't think that, the input mismatch isn't even checked for, so we'll have to, oh no, I guess it is. This is another type, so we'll talk about that under a separate example. So we're going to do the following. So enter a product. So I'm going to enter in 5 letters. Improper code length. So notice that for improper code length, we know for sure that string index out of bounds exception was thrown because it says improper code length when that happens. And that's because it tried to substring the string and it wasn't long enough, so it threw a string index out of bounds exception. So that's how we know that that's one of them that can throw a string index out of bounds. And if I change this back to 9, because I let the cat out of the bag, if I put in, say, a long enough number, but I don't make it 10 characters long, because it's going to try to do a car at 9, just like it tried to substring out to 3-7. If there's nothing at position 9, it will also throw a string index out of bounds exception. That's sort of the same as trying to substring just in one position. So you just grab that one from, make sure which one is this one. So I'll remove some. I had to return this. So if we look at this number here, I'm just going to edit it before I put it in. The place where the R is where the car at is. So I'm going to remove R-12 so that it stops at position 8, 0 through 8 as part of the string array. So I'll remove R-12, and it will also now throw a string index out of bounds array. So it says improper code length, which we know is from the string index out of bounds. So that's because it tried to find a car at position 9. There is nothing at position 9, so it threw the index out of bounds. So recall that strings in Java can be thought of as arrays of characters. If you begin at position 0 and go all the way out. Okay, so let's see. Number format exception. So improper code length. So let's see what this means. Let's take a look at that number that I originally had in here. So it was R-12. So the number that it's probing for is with the substring. So it's going to be substring 3 to 7. So the code length is, I believe, this one. So let's enter in something where it's 170 and then put in a character. Let's see what we get. Just to probe the program and see if there is any exception. So we know this is a known good code. We'll just choose a little bit. Make this a 0. This in. District is not numeric. So the district is the substring of 3 to 7. So let's look at where this is in the program, where it says district is not numeric. Let's see where this type of error or exception is thrown by the program. So there we go. So the district is not numeric. Number format exception. So that one, you've got, let's go up and look at the places where this could have possibly come from. And you can guess where, what generates this error. So we've got, so the district is integer parsing 3-7. So yeah.
Can you just scroll up for a bit, please?
Up to the top of the program?
Yes, please. Okay. Okay. Just because I kept getting an infinite loop.
So, what part do you want to look at or talk about?
Let's see. Actually, I got it now. Thank you.
Okay, so we've got district integer dot parseInt code dot substring 37. So this is where I had entered in a 170 and then I put a Q instead of finishing out the 4 digits. So this was caught by the number format exception. It does look a bit like the input mismatch exception. However, let's try it because this part I haven't tried. So let's just experiment with it. Meaning, if it was looking for an int when you enter in the value for the string itself. Say that I wanted next int instead of next line. That would be a genuine input mismatch exception. Let's see if we change number format exception to input mismatch exception, if it will catch that. Or since it's only a substring, we need to use the number format exception as a special exception type, since it's not the original thing being scanned in to the scanned object. You follow my gist? So down here, it's gonna comment that out. And let's try to change it to input mismatch so that when district is going to scan in part of the string into an int, if it will also allow us to catch it with the input mismatch. Okay, so now we'll try to do that again. I'll put in the same value, and we'll see if it will be called using this one, just to see if there is a requirement or if there's a flexibility. Let's try that again. Okay, so it did not. So now we see actually this is how the compiler is handled. If you thought that you caught something but it throws an exception, it's really an exception. You're given the exception you have to catch, so it's easy. It's like through a number format exception, you catch a number format exception. So now we see that even though it is like an input mismatch exception, that will only work when it's an input mismatch on the original scan. Like when you scanned in the string into from next line, say if that was an int, then that would have worked if we put in a character. Since it's only part of the string, that won't work. We have to detect the substring mismatch using the number format exception. So that's how that works. So like when we originally did this program, where it was the input mismatch program, and then we had said enter a number, input that next int, and we were storing it in int. This will be caught by input mismatch exception because it's checking the original input into the scanner object. But if you use a substring after that to take out part of the string at all, then it's not into a mismatch exception because the string is just a string. So you could have just taken a string that was declared at the beginning of the program and then substringed it, so the compiler wouldn't know one way or another whether it was originally from input or not, so then you have to use number format exception. But again, it's easy just to look at which exception is thrown, copy the exception name out, and do it like that. Go back to your program, find the place where you have the exception filled in, go to write the exception for each side, and then run it again. And then see if the new exception is caught. So that should work. And there we go. So number format exception for parsing string. So it's the string index out of bounds. Did we do the? Yeah, we didn't do the one where it was too short from 9 yet. So let's do that. So we can also throw the string index out of bounds exception. So notice that this is the 9th place. So maybe we did this one already, but let's do it here. So where the R is a car at 9. So I think, yeah, we did the string index out of bounds. Let's change this to a number instead of a car. And then we'll get perhaps the number format exception, although we'll see which one we get. So notice that if I do the one where it doesn't have the 9th place, we'll get the proper code length because it throws a string index out of bounds. But if I make the R a number, then there is a 9th place, but it's not what it's supposed to be. So let's see what we get. So district is not numeric. So that's also catching number format exception. So notice that it was looking for a car and we put in a number. And number format exception also caught that we wanted a car but we put it in int together.
That's district because you still had an A instead of a character for the parse int. You just copy pasted it in, and so you did not make it. Yeah.
District is not numeric. So thank you. You're right. Right. So let me change that back, and we'll see what we get. Yeah, you're right. Thank you. So the exception that we got was district is not numeric. So, well, you are correct. So I'll change it back. But do notice that the message for number format exception is district is not numeric. So let's change it so that the district is numeric. So without the 9th place being a number, let's see if we get also a number format exception. So what we're going to do is we just clear the console. So what we're going to do is put in, so we'll put this back to a number. Let's just put it in correctly and see if this accepts as a totally correct number. And then I'll change the R to a number, and we'll see if we also get district is not numeric. And then at that point, we'll see that the car switch from to an int is also being caught by the number format exception. And it throws an error, and then it's going to cancel out of the program. Then we know we have to handle it otherwise. So that one's good. So we know that one is correct. Let me get this. Sorry, you can see it. Okay, so now I'm going to change this to. So district is not. Sorry.
So what's the district?
No, I still didn't have this. The district is the 9th position, counting from 0. But I still had this as an A. So it does accept it, right? So that did not throw an exception. However, that is a problem. So if we wanted to throw that as an exception, we would have to Well, we couldn't use any of the ones we have, so thanks for pointing that out, Jeff. So the reason that it wasn't thrown in, I thought it was being subsumed under this, but it wasn't. It was the fact that I had still left the sixth position as. So we're going from our originals. This one was caught as a number format exception because this is supposed to be linked from the substring 3.7. Car at 9 looks for the thing that's at this position, but it doesn't mind if it's not a letter because, as we know, numbers are also cars. It's just that if you really want a letter character, you can probe for it, but you just have to say the character string number. The ASCII code value being between 97 and something else for the lowercase, and something else and something else, 26 letters for the uppercase, but it wouldn't be, it seems from this one, so there won't be an easy way to do it. Well, it'll be easy, but it won't be as simple as the track match. And then if we remove this and only had it up to 7 with all these being numbers, then it will be a string index out of bounds error because the car at is treating the whole thing as a string array of characters, so it looks for array position 9. If there's not one there, it will throw the array index out of bounds. So let's just see that one fast before we just see it again before we move on. So if we do, so we have this one. If I go just like that, now the position 9 doesn't exist. This will throw an array index out of bounds because it's looking for something at position 9. So in proper code length, which is the array index out of bounds error, if we change car at to a 5, then this would be okay. But it's looking for something at 9, so 9 is everything. Any questions about the program so far?
Just a few things in general.
So we see, it's a flexible way of taking in input of any kind and probing the input for the stuff that is needed. There's no way to take in some bits, some characters, allowing a dash because ints won't allow that, doubles won't allow it. You have to use a string, which is a catch-all, and then make sure that it's in the proper format to do so.
Are we supposed to use input mismatch demo in this program?
I was trying to see if it would work, but it didn't work because, I guess the reasoning makes sense because input mismatch is only really for looking for when the data is originally scanned in from code equals scan the next line. So anything is allowed into a string. So that's going to be hard to throw an input mismatch exception. If code was an int and we wanted all integers, and you put in a character, then it would throw an input mismatch exception. But since code is a string, when we're looking for the ints down here, it's not strictly freshly inputted anymore. It's just parsing part of it into the int. So this is the number format exception.
I see.
So then we see also, we want to make sure that it ends correctly. It says while code doesn't equal uppercase X, then keep giving the user the opportunity to enter data. There is generally if you have some type of input thing like this, you probably see if you ever do any counting system work. Usually the code would be put into all uppercase so that everything could be checked very easily because if somebody enters in lowercase xxx, it won't stop the program, which you would expect it might, but it doesn't. So you can just do a two-upper, for all the characters, and then all the rest should be okay. Just don't check for anything lowercase. And if you do a two-upper on numbers, it's not going to affect the numbers. It's not going to affect the dash. So that would be okay. Yeah, so let's just do the end part. So let's show that the program is valid when it does it. So we have down here where it is still waiting for input. So if I enter in lowercase x, it's going to say improper code length, I think. Improper code length, because it's taking it as an attempt at a valid input, but it's not long enough to do the substring, so it throws an array index out of bounds. So if I put in uppercase, then it finishes. And then it gives you a report on the codes that were used. So if the code is too short, then it's not valid. If it's valid code, it means that it had the proper length, had the 4 numbers beginning at 3 going to 6, and then that would be considered valid. So it just gives a brief report on the types of codes entered. And again, those report values were generated here. So if the ninth position had an uppercase R and the district was 2000, was greater than 2000, so if it was 2001 or above, then it would be considered one of the band, arbitrarily banned. And then it would be considered valid if it did not have an R and a district of 2000 or above. So let's see if that part works, then we'll move on. So let's enter in where a district has R and then the district number is 2001, and then let's stop the program. And let's see if it gets reported as banned. See if this works. Okay, so I'm going to make this 2001. Okay, so it accepted it, but now let's see, we'll just stop it and let's see if it reports it banned. So valid codes entered. Valid means it had the proper everything in there, like numbers in the spot, etc. But it was one of the banned ones. Because the ninth place, there's an R, and then the substring 3 to 7 is 2001, which is above 2000. So now let's enter one that has everything the same except for it has 2000. So we'll have part of the Boolean, but not the other part. Let's make sure that it works. So it should report as valid, no ban. So if we put this one in, this will not satisfy the whole Boolean because it will not be greater than 2000. It will be 2000 itself. And so it says valid code 1, ban code 0 because this is not 2001 and R, it's just 2000, and then there's the R, so it doesn't satisfy the Boolean checking for and values. And of course, we know that if you wanted to do something different with the Boolean value, you can always say, you can always put in ORs. So if we put in OR, then we should expect that input to give a band value because it will not satisfy district greater than 2000, but it will satisfy zone equals R. And we know that OR is one or the other. So we've got, so the greater than 2000 isn't there, but the R is. So this one should come up as valid and banned, because we changed the Boolean from and to banned and valid. So the Boolean values will bring out ors. One of them is true, then it's true. With the and, both have to be true, or it's false. Okay, so the exception class hierarchy. Let's just go through this when we're going to hit the example using a checked exception. So let's just see what an example of a checked exception is, and then we'll go back and look at the hierarchy, because it'll be easier to see when we look at what a checked exception looks like. So we'll create our own exception after we look at the checked exception. So this where it says writing text files. If you try to do writing to or reading from a text file in Java, it has the possibility of throwing an IO exception. It's a place where you look for the text file. Could be the text file could be not there. So this is a checked exception, meaning that it is something that the compiler will make you check, either in using try catch or by throwing the exception, so that you are stating clearly in the program that you know this exception is in existence, and if you just throw it, it means, which we'll see, it means that you know it's there, but you really don't care because if it happens, whatever. But that's bad because then your program crashes. You want to put it in a try catch block. But you can use the throws keyword, which we'll see how to do. But then we'll handle it using try catch, which is much more good idea. So let me see if I have my text file here. So this is the one that's going to just throw. So as soon as I get this into Eclipse, we'll eventually throw something in place. And as a point of conversation, the exceptions we've been dealing with so far, number, format exception, input mismatch, arithmetic, those are not checked exceptions. Because as we know, you can run the program without those try catch blocks, and the program might have a problem. The compiler will allow you to compile it. With a checked exception, which the IO exception is one of them, it will not compile. It's a compile time requirement to state that you know that this exception is there. You're either going to handle it or not. You have to state so. Okay, so we got this program. So I'm going to go ahead and just comment out this throws line right there. And now we're going to get an error. But we're not going to get an error on the class. We're going to get an error on the line that has the possibility of throwing an IO exception. So we'll find down here somewhere. There's going to be, okay, so we see right there. So it says, unhandled exception, file not found exception. So this is an IO exception. So if we uncomment the throws line, this is handling this exception. However, we'll run it that way and then we'll see that it works. But if the file really isn't there, which I'll remove it, then the exception will cause the program to crash. Whereas if we do a try catch, it will gracefully handle the exception. But by taking the throws away, we see that this is the line that we're going to have within our try catch block at some point. This is where the exception happens at this point. And notice that it says, it's like file name, so test.txt. So this is first going to make a new file. So first let's just run the program the way it works. And let's see if it works the way we want it to before we start changing this and seeing what throws will work and doing the try catch. Let's just see if it works. So it won't work. So the place where the text file is going to be made is somewhere where the Java file is. So you can always just go over and right click on the Java file, go to properties, and then click on the place where it tells you the location of the file. And from my experience, the place where the text file is usually made is within the folder name, but not within source or bin. Well, let's just run it and see where the text file appears, but I think it's going to happen right here. I mean, we should see a test.txt appear after we Okay, so going through the program, we see that there is a string name, we see a print writer line, which we'll look at soon enough. Essentially what it's going to do is it's going to print to that file, which doesn't exist yet, some set of numbers. So this is how you can use Java to write a new file. So it's a pretty powerful thing to do, writing a file using the program. You have to have folder access, etc. Let's review. So output file has been created, test.txt, which we have to take the compiler's word for it unless we can go to the place where we look for the actual file. So now the place where we looked for a file and there wasn't one, we see there's a file there now, and the time on it is 10:55, which is now. So if I open this, there should be some stuff. So let me open it. So we see there's some numbers. And
How do you get the compiler to open the file, like to create the file?
by using the print writer to output file takes the string name, which is test.txt. So the string file name contains the string test.txt. Print writer is going to print all the stuff down there into the file test.txt. So print writer is a Java object which allows you to write to files. So the print writer object out file is going to use the string object test.txt to put all these numbers in. So file name equals the string name test.txt. Out file is a print writer object, which is going to be used down here to put all those numbers in. So we got to look for out file once we get down into there's double folders, and that's where the file will actually be written. So we go right here, out file dot print, and then out file dot print line. So this is where it says value plus, and then out file dot print line. This is where it prints a value, and then it does a line break, etc. So you can format how it goes. So the out file is the print writer object, and then it uses the string name that you give it when you piped it in to the program, and then it closes the print writer objects. So after we run this just a couple more times, because we'll see that it will overwrite the file, I'm going to use Windows security to block access to the file. And then when the program tries to write the file again, it's going to throw an exception. So we'll see that the throws doesn't really work as well as try catch, and then we can do the try catch to do it. So if this were a read, that would be easy because we just make the file not be there. But since it's a write, the only thing you can do is either protect the folder from writing to it at all, or change the security on the file so that it's not available, which is easier. So I'll do that, and then when it tries to write to it again, it won't work. So let's just open that file again to see that it will make a new one. So it starts out at 22, it ends at 93. So I'm going to run the program again. We'll see that it actually just makes this a new file. And we see that it's, the timestamp is 2 minutes later. So now it's beginning at 27 and then 60. So it's a different file. So it does write to the file over and over again. So since it's there, I can change security, and now there will be an exception from, because it won't be allowed to write to the file. So we go here, we go to properties, and so let's say edit. Sure, it's a window security. Okay. So notice I can't even open from the mouse, so we know the program. So, you know, that's something you can do in Unix and in Windows, etc. So now when I run the program, it's going to try to write the test that at the end. But just like when I tried to open it, the program's going to try to open it to write, and the operating system is going to give it the information. It's going to throw the I/O exception. So we got. So this says file not found, exception error with thread name, and we see all this stuff because even though there is a throws, it doesn't handle the exception at all. This is just the fact that, unlike say division by zero error, which you can run the program without try-catch and it will crash, if we remove the throws I/O exception, the compiler will not compile it for you, because you have to acknowledge that this type of exception is possible, because checked exceptions are things that software designers are expected to be able to look for in advance, because it's always possible that a file isn't there. So checked exceptions mean you must account for it either by using the throws keyword or by more properly using the try-catch methodology, so that we can actually catch it and then allow the program to flow until properly. So this is just the program normally crashing. The throws I/O exception doesn't do anything. It just allows you to compile it. Okay, so now we still have our test.txt not being open. So let's change it to using try-catch instead. So just a couple of slides later, somewhere. If I don't have it, we'll just edit it. So here's one where there is a try-catch and it does not need the throws I/O exception. So we'll take a look at it. You know, actually, let's compare them side by side. Let me just put this into Notepad. So we've done the one that throws the I/O exception, and this one that does not throw it, but it can. So we see that it doesn't have a throws, however, it's got a try. So it's got a try was a place where we saw when we removed the throws, there was an error bar on print writer, out file equals new print writer file name. We have to put the try at least before that, because that has to be within the try block, because that's what throws the I/O exception. So let's just make a file for the new version. Okay, so notice that there is no throws. However, there is the try block. So if I hover over the parenthesis or the curly brace, we see that the entire try block goes all the way down to this one. And that's because, as we know, a try catch block has local properties. So if we put the out file part in the try block, and then we try to use out file outside of it wouldn't work. So if you want to use out file, everything that uses out file has to be within the same try block of curly braces. So now this will work, and it will catch the IO exception. So instead of just a catch IO exception, we name the object instead of saying throws, and then this will gracefully allow the program to end instead of just having it crash. So we see down here catch IO exception, and this will say file IO error. And let's also leave a line at the end of the program so that we know that it actually finished gracefully. So this should be still in the name right here. We can just so we're still going to have an exception because test.txt is still it's still got a problem. So just to show that this program works the way it's supposed to, I'll change the file that it writes to test2. This way it can write the file, but then we'll try to have it write to test, which we know is blocked from Windows security, and it will throw the exception, but it will stop reading.
Can you scroll down to the program?
So we see that it worked correctly.
Can you
Create
scroll,
the file and says,
can you scroll down to the random number generator? Just had a question here. Yeah, right there. So for our random number generator, it starts at it's from 10 to 100, right? Because 90 plus 10 is less. Or is it like from 10 to 100 or 10 to 90?
let's see, 90 plus 10. Well, what do you think? What do you think it means when you have a 90 in parentheses and then plus 10 afterward?
I think it would be like to 100, like up to 100, because like it starts at 10, right? Because
Right.
yeah.
So the in parentheses is the span. Where you start from is the plus number. So starting at 10, do 90 numbers. So it would be 10 to 100. If you wanted 100, going from 1, 100 plus, in parentheses, plus 1. So that's correct. Okay, so we saw that it writes the file correctly. So let's look for the file test2. So we see that this one does it, and the one that is called test still doesn't open. So let's try to have it write to test, and then we'll see the exception handler work the way we hope that it works. Change this to test again. And now we see file IO error end of read. So much better than the exception throwing just because we wrote throws IO exception. If you work somewhere and you throw all of your exceptions that are checked, you're certainly not going to be a big superstar because you have to try catch all of your exceptions. Throws is just for if you want to check your program and you want to throw the error because you know it's going to work. You can do that first, but you want to have try catch in the program, not throws. Throws is simply a way to get your program working quickly, but you do need throws if there is an IO error, because it will not run without either throws or either try catch. It will be one or the other because IO is a checked exception. Arithmetic exception is not a checked exception. We know when we did our catch, as we know, it's going to be, but we knew that the try catch, when it wasn't there, it didn't stop it from being compiled. It compiled, but then it stopped. So an arithmetic exception is not a checked exception. So you can look up the Java documentation. We have a couple of exceptions mentioned here. But the reason we looked at that was so that you can see what the checked exception, what that means. So my PowerPoint possessed. Let's wait for PowerPoint because all the slides have decided to be blank. If not, I'll just open it a little bit. And, well, I know that there aren't any extra slides because there were 38 slides in here, so PowerPoint is doing something weird. Yeah, pretty weird. Oh, they came back. I guess they were off in the middle of the screen. Okay, so the checked exceptions, we saw, well, the IO isn't even on here. So the checked exceptions are, at least the ones here, a legal access exception, no such method exception, class not found exception. But there are a bunch of others. But notice that the ones, arithmetic exception, index, out of bounds exception, null pointer exception, those are kinds that can happen with a runtime, but they're not checked exceptions. So there's a whole bunch of those, and there's a whole bunch that are checked. But as far as exams, you'll know which ones you need to know for the final, because the only checked exceptions you'll need to know would be in the review or in the lecture. You don't need to know all.
So is this saying that if you did like a try or an attach, you could put a runtime exception, not attach all of those? Or is that just saying?
No, this is just like describing.
I see. Okay. I see.
So a runtime exception is any exception at runtime, whether they're checked or unchecked, is depends upon where they are. And then errors are different. They're not exceptions. Errors, it's a compile time error. It won't run. You can't try catch it. It's just an error. It won't compile. So exceptions are it runs, then stops. Errors or it won't run at all because the compiler will not compile it yet. So we see here already, we've seen arithmetic exception, we know that it's unchecked. Index out of bounds exception, we know that it's unchecked because the program we ran, product codes, it didn't say throws, well, although I guess it did have try catch. So if you take the try catch out of product codes, the index out of bounds will not throw. It will only happen after the run because it's an unchecked exception. Unchecked means you don't have to have throws, you don't have to have try catch. Check means either throws or try catch is required. But throws is not the best way to do it. Try catch is the better way. Okay, so let's see. So if Sanchita shows up after the break, we'll do a lab, and if not, we'll see how to make your own exception. Write your own exception object and see that you can throw it. You can also do a try catch of your own object, but it's much more involved, so we'll just do throwing your own custom type of exception. And how to write the object up and call it within your program. So let's just do a 10-minute break and come back and do that.
Do you have a YouTube channel?
Yeah, it's for streaming classes.
It's a Twitch stream?
No, it's a YouTube stream.
So you just stream.
Putting this up so people can see better. Like those aren't working.
Are they uploaded permanently after this stream?
Yeah. It's over there. Yes, sir.
What's your YouTube channel?
Let me just send you out. Solid coder SV3 coder underscore SV3.
Coder underscore SV3. You subscribe to me, right?
Yeah, I did.
Okay, I'll subscribe to you. Twitter SP3.
Yes.
SP3, right?
Yes.
Okay. Yeah, time to hang out Friday, right? I just forgot to text everybody.
Yeah, no problem.
Okay. I don't know how to get the Smash Club. I don't know if he's gonna join us for dinner, but we'll see.
Let's see.
I gotta ask. Oh, did you get a text back from me?
Yeah, I handed it.
I'm gonna hand in mine. Professor, it's my test practice for last one.
Number 21. This is the last.
Wait, Roger. You do realize that
Can you spell your name?
I thought I did. I tried to do it. I can put it again. Does that earn all the points back? Like this?
It's like,
We gotta let me look, so if you really want
Alright.
Yo,
I
he's in CIS.
had already done it, so I just like.
Okay.
It is.
Wait, Tuesday. He's on Tuesdays. I got a thing at 1. It's Tuesday, yeah. Tuesdays I got a thing at 1.
Oh wait, you have it on.
Sunglasses for like the summer, like now.
Let me check my calendar. Do we have an SLS event today?
And like